May 2025. Elon Musk stands in front of a massive screen talking about colonizing Mars. The crowd is going wild. The press calls it a revolution. Millions are watching live. 70 years ago, people were saying almost the exact same things. Scientists, engineers, dreamers. Except they weren't looking at Mars. They were designing spaceships, sketching planetary outposts, and publishing peer-reviewed papers about warm oceans and dense jungles. This wasn't science fiction. These were the serious calculations of Nobel laureates. The planet was Venus. And then we found out the truth. June 1761, St. Petersburg. Mikhail Lomonosov, the man they called the Russian Leonardo da Vinci, points his telescope at the sun. Today is a once-in-a-century event. Venus is transiting directly across the solar disk, a tiny black dot against a blazing wall of fire. He watches the edge of the planet's silhouette and sees something unexpected. A thin, glowing halo, barely visible, as if light itself is bending around the planet. An atmosphere, he realizes. It has an atmosphere. That discovery should have changed everything. Instead, for the next century and a half, Venus remained a mystery hidden behind a thick blanket of clouds. And that mystery became rocket fuel for humanity's boldest dreams. Because if it had an atmosphere, maybe it had life. Through the 1920s, scientists assumed Venus's atmosphere was similar to Earth's, mostly oxygen and nitrogen. And what lay beneath those clouds? Oceans, obviously. The thinking of the era was straightforward, and Nobel laureate Svante Arrhenius said it best. If there are clouds, there's water underneath them. A planet closer to the sun must be a lush tropical paradise. Endless rain, steamy jungles, warm seas. Then spectral analysis showed there was no oxygen, just CO2. But even that didn't kill the dream. Scientists suggested the carbon dioxide was simply the byproduct of explosive plant growth, like Earth during the Carboniferous period. This was the mid-20th century. Sputnik hadn't even launched yet. But any school kid could tell you the solar system scorecard. Mercury was a scorched rock. The moon was dead and dusty, the canals on Mars were a myth, and everything beyond was frozen solid. Venus was the one planet that still made sense. Most scientists agreed it was hot, and almost certainly wet. Beyond that, anything was possible. Desert or jungle, barren rock or thriving ecosystem. A few even speculated that if Venus had life, why not complex, maybe even intelligent life? A minority ran the numbers on the planet's high albedo and argued the surface might never see sunlight. So perhaps it was dark and cold, or bright and covered in snow. Almost no one questioned whether there was water. Earth had plenty. Mars had ice caps. Venus obviously had water too. Those maddening clouds were pure gold for science fiction writers. They could paint Venus however they wanted. No one could prove them wrong. While Mars was seen as a dying desert, Venus became humanity's dream of a living world next door. Earth's sister planet, full of possibility. Closer than Mars, almost the same size with 90% of Earth's gravity. October 4th, 1957. The Soviet Union launches the world's first artificial satellite, a simple metal sphere with antennas. It doesn't do much, it just flies and beeps. But that beep changes everything. Space is no longer abstract, it's reachable. And if we can put a satellite in orbit, we can send a probe to the moon. And if we can reach the moon, why not Venus? In the hallways of Soviet research institutes, in NASA conference rooms, and in the offices of science journals, the conversation shifted. People stopped asking, can we, and started asking, when? Venus was priority number one, closer than Mars, shorter flight time. The race for Venus had begun. There was just one problem. We still knew almost nothing about Venus. Not the temperature, not the pressure. Not what was really hiding under those clouds. An orbiting satellite can tell you a lot, but Venus was different. The only way to get real answers was to go inside, to send a probe straight into that atmosphere and see what happened. Engineers faced a basic question. What exactly were they building for? The theories were all over the place. Carl Sagan had developed the greenhouse effect model and predicted hellish surface temperatures. British astronomer Fred Hoyle argued, with actual data, that the entire planet was covered in a global ocean of oil. Estonian astronomer Ernst Öpik claimed the clouds weren't water vapor at all, but a planet-wide dust storm. The numbers, though, came out roughly the same as Sagan's. Radio astronomers were picking up strange signals suggesting surface temperatures of 300 degrees Celsius or higher. But was that the surface, or just the upper atmosphere? No one could agree. This was the state of human knowledge when the first Soviet probes left Earth. We didn't really want the truth. We wanted confirmation of the dream. That's why the ocean theories and jungle theories kept winning. Not because the evidence supported them, but because people needed to believe. 1961, the Soviet Union launches Venera 1, the first spacecraft ever sent toward another planet. It carried no scientific instruments. The mission was simple: hit the planet and plant a Soviet pennant on it. It failed. The probe lost contact mid-flight, passed about 100,000 kilometers from Venus, and went silent. But in a strange way, it was still a success. The ballistic problem had been solved. A spacecraft had left Earth's orbit, traveled across interplanetary space, and flown by another world. Meanwhile, the Americans weren't sitting still. NASA launched Mariner 2. No cameras. Scientists assumed the clouds would block any photos anyway. Instead, they loaded it with radiometers. Mariner 2 flew within 35,000 kilometers of Venus, kept its instruments running, and transmitted data all the way home. It became the first fully successful mission to another planet in history, and it killed the dream. Mariner 2 confirmed what the optimists had refused to accept. Venus was no tropical paradise. Surface temperature, around 425 degrees Celsius. The atmosphere was crushing and almost pure carbon dioxide. Any hope of Earth-like life was gone. After Mariner 2, the United States largely moved on and shifted focus to Mars. But the Soviets saw an engineering challenge and kept pushing. Venera 2 and 3 failed. Venera 4 transmitted atmospheric data during descent before being crushed by pressure. Venera 5 and 6 met the same fate. Disaster after disaster, nearly a decade of attempts, and no spacecraft had survived long enough to reach the surface. At the same time, there were far more ambitious plans. As early as 1959, before there was even a cosmonaut program, Sergei Korolev had already put together a team to design a heavy interplanetary spacecraft. The concept was brutally simple: 3 cosmonauts, 1 year in a cramped cabin, no rescue, no resupply, just the void and each other. The ship would be launched by the giant N-1 rocket and sent to both Venus and Mars. Planners quickly realized something useful. With the right trajectory, one spacecraft could visit 2 planets in a single mission: a gravitational slingshot around Venus, then onward to Mars, or vice versa. 2 worlds for the price of 1. The math worked almost too perfectly. But the engineers knew the trajectory wasn't the hardest part. Keeping 3 people alive and functional for 500 days with no way home was a challenge. Their solution was almost surreal. The spacecraft would carry a living ecosystem. Algae would scrub CO2 and produce oxygen. Water would be continuously recycled. Hydroponic greenhouses would grow 20 to 50% of the crew's food. The ship would literally breathe. To prevent muscle and bone loss in zero gravity, the entire vessel would slowly rotate, creating artificial gravity. Giant antennas would unfurl in the darkness. Solar concentrators would focus light into the greenhouses. This wasn't just a spacecraft. It was a small artificial world built to cross the solar system. Korolev believed it was possible. His team believed it. But 4 catastrophic failures of the N-1 rocket buried the entire interplanetary program, and the Soviet lunar program with it. The Soviets had built their dream from scratch. The Americans took a different path. They looked at what they already had and asked how far it could go. NASA didn't have a dedicated interplanetary ship, but they had the Saturn V, the most powerful rocket ever built, the one that sent men to the moon. Inside NASA, people started asking, what if we pointed it somewhere else? As early as 1964, years before Armstrong's first steps, NASA announced the Apollo Applications Program. Among the proposals was one especially bold idea: a crewed flyby of Venus. 3 astronauts, 1 year in space, 1 pass by another planet. The solution was elegant. The rocket's 3rd stage, the huge S-4B fuel tank, wouldn't be discarded. Instead, it would be vented, purged, sealed, pressurized, and turned into living quarters. A home in space made from hardware that was already going along for the ride. The trajectory was calculated, the mission architecture was ready. It never happened. Congress kept cutting NASA's budget. The grand plan shrank into an orbital station, and that's how Skylab was born. Venus was left behind. August 1970. Venera 7 heads for Venus. Objective: land on the surface and transmit data. Every previous probe had been destroyed before reaching the ground. No one was very optimistic. Just in case, engineers had built the spacecraft to withstand 150 atmospheres. 4 months later, Venera 7 released its descent module into the atmosphere. Almost immediately, things went wrong. The transmitter jammed. Only temperature data was coming through. Then the parachute tore. The probe slammed into the surface much faster than planned, and the signal cut out. Mission Control assumed it was dead. But one persistent operator refused to give up. He ran the recording through filters again and again, and found a whisper in the noise. 3% of normal signal strength. The probe had flipped on impact, and the antenna was pointing the wrong way. But it was still alive. 23 minutes. That's how long the battered probe survived on the surface of another planet, the first time in human history. In those 23 minutes, it sent the only data that mattered: temperature and pressure. Surface temperature, 465 degrees Celsius. Atmospheric pressure, 90 times that of Earth, like being nearly a mile underwater. This was no tropical paradise, it was hell. Yet it was also a tremendous victory. Venera 7 became the first spacecraft in history to land on another planet and transmit data from the surface. 5 years later, Venera 9 touched down and sent back the first photographs from the surface of another planet. Black and white, but real images. Through inch-thick quartz glass, the camera saw a rocky desert. Scattered rocks everywhere, lighting like an overcast day on Earth. Dust kicked up on landing and settled quickly. The air was surprisingly clear. And yeah, no dinosaurs. Venera 13 and 14 later delivered the first color panoramas and drilled into the surface for chemical analysis. Venera 13 even recorded audio, the first sounds ever captured on another planet. You can still hear it today. The low rumble of Venusian wind, the thud of the lander, and the grinding of the drill. But after Venera 7 and Venera 9, the conclusion was unavoidable. The surface was a dead end. You could reach it, but you couldn't stay. The best Soviet landers lasted about 2 hours before the planet cooked them alive. Humanity turned to Mars, officially a more promising target in the search for life. Unofficially, Mars was still a place where you could dream. Cold, barren, and miserable, but it wouldn't destroy your hardware in an hour. It had polar ice caps. It might have had water. It might have had life. Same words, same logic, same confidence. But what if we'd been looking at the wrong part of Venus this whole time? The surface is hell, that's settled. But 30 miles above it, everything changes. Pressure is close to Earth's. Temperatures hover around 60 degrees Celsius. Brutal for humans, but manageable for machines. Plenty of sunlight for solar power. By solar system standards, it's one of the most accessible environments for human presence after Earth itself. And you can send an airship there. NASA calls it HAVOC, High Altitude Venus Operational Concept. A giant helium-filled airship, the length of 2 Boeing 747s floating through the Venusian clouds. First robotic missions, then a 30-day crewed stay, then a year, and eventually a permanent floating station above the inferno below. It's still just a concept, no funding, no timeline. But here's what's interesting. A century ago, Konstantin Tsiolkovsky, the father of Soviet rocketry, dreamed of a metal airship the size of an ocean liner. He knew nothing about Venus. He was simply dreaming about the sky. Maybe the dream never really died. Maybe it just found the right altitude. May 2025. Elon Musk stands in front of a screen talking about colonizing Mars. We've seen this before. Different planet, different name, same speech. We're designing ships to a world we don't fully understand. We're convinced there might be a place for us there. We believe it as sincerely as scientists believed in Venusian jungles in 1955. Maybe this time we're right. Or maybe 70 years from now, someone will make a video about how humanity lost its second dream of another world. We don't explore space just for knowledge. We explore it for the dream, the belief that somewhere out there, there's another place for us. When Venus killed that dream, we moved it to Mars. We'll keep moving it until we find what we're looking for, or until we realize we've been looking in the wrong place all along. And maybe that's not a flaw. Maybe that's the only reason we ever looked up at all.